Welcome to Physics Class 12th, Unit 6 Optics, Chapter 9 Ray Optics. And this is the first video of this chapter. In this video, we will discuss refraction of light, law of refraction, principle of reversibility of light, refraction through a rectangular glass slab, it is also known as lateral shift, refraction through compound slabs, different slabs, apparent depth in a liquid, that is called normal shift, and total internal reflection. This is the second book, starting of second book of class 12th, and this is the unit called optics, bifurcated in two chapters, ray optics and wave optics. As we discussed in class 10th, light follow dual nature, ray nature and wave nature. Sometimes we discuss phenomena of light as consider as ray, and sometimes we discuss consider as wave. So in this chapter we discuss ray nature of light. So first of all, reflection is not in a syllabus as updated syllabus by CBSE. So the first topic of today's discussion is refraction of light. What is refraction? Refraction can happen in sound also, in heat also. Now, but here is our concept regarding the light. So what is refraction? So refraction is a phenomenon of change in path of light as it travels from one optical medium to another. When a ray of light travels from one optical means rarer to denser or denser to rarer. When it travels from one optical medium to another, then it's change its path. If it travel rarer medium to denser, then it must bend toward the normal. Rarer to denser, then it bends toward the normal. It means if it travel from air to glass, it travel and it bends toward the normal. If it travel denser to rarer, if it travel denser to rarer, then it bends away from the normal. Then it bends away from the normal. So these are the two cases which we will discuss earlier. Rarer to denser, denser to rarer. These are not a law, these are the conditions which can be possible in refraction of light. Now, what is refraction? So refraction is a change in path of light. What are the law of refraction? We will discuss here. So diffraction, when a rarer to denser, it bends toward the normal, and denser to rarer, it bends away from the normal. So I and R. I is angle of incidence, R is angle of refraction, but in second case, as a parallel rays, R have alternate angle are same, so R and R are same here. So since it is a reversibility, so I is again here same in same. Now law of refraction. First law, the incidence ray, normal, and the normal to the refracting surface at the point of incidence and the refracted ray lie in the same plane. It means incidence ray, refracted ray, and normal lie in the same plane. Second law is also known as Snell's law. The ratio of sine of angle of incidence to the sine of angle of refraction is always constant for a given pair of medium and given wavelength. The ratio of sine of angle of incidence to the sine of angle of refraction is always constant for a given pair of medium and given wavelength of light. It is also as a formulate mu equal to sine I upon sine R, where mu is called refractive index of medium, I is angle of incidence and R is angle of refraction. Now in refraction, velocity and wavelength can change, but frequency always remains same, and phase of light is also not change. But we discussed class 11th in reflection, the phase will also change. The formula for mu is equal to C upon V, or we can say C in air upon C in medium. And if in A to medium, it can also is discussed the wavelength in air to the wavelength in medium. Frequency is always remain same, so frequency will same in both medium. Now principle of reversibility of light. Light can travel from one medium to another. Light can get reflection, refraction and multiple phenomena. But if we provide the reverse path of to the light, in any case it will comes back in same path. It will comes back in same path. So it's called principle of reversibility. Initially the I is angle of incidence and R is angle of reflection. but when it comes back in same path, we place here a mirror, plane mirror with 90 degrees, so it comes back in the same path. Now R is the angle of incidence and I will be angle of refraction here. So it is called principle of reversibility. A mu B means a medium A to medium B is sine I upon sine R. But when it travel from B medium to A, then sine R upon sine I. R considered as incidence and I consider as refraction. Now multiply both of them, then A mu B into B mu A is equal to 1, or we can say A mu B is the reciprocal of B mu A, or we can consider as multiple medium for same also. So if a ray of light after suffering any number of reflection or refraction has its path reversed at any stage, it travel back to the source along the same path in opposite direction. It can also happen with compound slabs. We can take an as multiple slab with multiple refractive index, different refractive index, and light travel from medium A to B, B to C, and C to again A. So the three stages are here: I1, R1, I2, R2. Or we can say R1 and R1 are same because here the parallel rays are here. So if it is R1, then it is again R1. Then this is R2 and this is again R2. And this is finally, it is important, it is I1. When it comes back in same medium, the angle of incidence and angle of refraction for overall is same. It means it will be parallel to incidence ray. So A mu B is equal to sine I upon sine R1, as we know here, sine I 1 upon sine R1. For B mu C, it will be sine R1 upon sine R2. And C mu A is the sine R2 upon sine I1. If we multiply all three, then we of course get 1. It means the path is undeflected. It is parallel to incidence ray. Or we can get A mu B into B mu C equal to A mu C. It means if we skip any one of the stage, but the path remain parallel. Or we can say A mu B into B mu C is equal to 1 upon C mu A. Or B mu C, you can say A mu C upon A mu B. So the relation between different kinds of refractive index. Now refraction to parallel glass slab, or we can say rectangular glass slab. It will be better to suit a rectangular glass slab. So if light passes through rectangular glass slab, we discussed in class 11 that follow two types of law. First law is emergent ray is always parallel to incidence ray, and second is angle of incidence is equal to angle of emergence. So the incidence ray is parallel to emergent ray, or angle of incidence is always angle of emergence. But here is a shift in the path. Here the shift, parallelly shift in the path, that is called parallel or lateral. Left right जैसे दो हाथ होते हैं. So these are the lateral shift between the incidence ray path and the emergent ray path. So we have to find that lateral shift when a ray of light passes through a rectangular glass slab. So I is angle of incidence, R is angle of refraction here. Once again it will be a same path, so it will be R again here, and this is called angle of emergence. And we know that angle of incidence is equal to angle of emergence when it comes back in same medium. So now this is I and this is R, so the remaining angle will be I minus R. In this case, we have to find the lateral shift. Uh, so we have to take lateral shift OM, that is labeled as small d. So we have to find small d, so we have to take two triangles, MNO and NOP. So in triangle MNO, we have to find sine I minus R is equal to perpendicular upon hypotenuse OM upon ON. So sine I minus R equal to D upon ON. Our aim to find D. So D is equal to ON sine I minus R. Now ON is unknown value here. So by ON we have to find by taking the triangle MNOP, NPO. So in triangle NOP, cos R is equal to base upon hypotenuse. So NP upon ON. So we have to find ON. So ON is equal to NP. This is the thickness of the glass slab. So small t into 1 upon cos R is written as sec R. So ON is equal to T sec R, or the final formula for lateral shift D is equal to T sec R sine I minus R. It is an important derivation in case of class 12th. Lateral shift, left right shift हो गया यहाँ पर, D is equal to T sec R sine Y minus R. Next one is apparent depth of a liquid, or we can say a normal shift. Normal means perpendicularly. So it is traveling from one medium to another, same because it is a refraction, rarer to denser. An object kept in the bottom of the vessel appear just little bit up to its actual position just because of refraction. As we see, the bottom layer of swimming pool appear just a little bit above to its actual high depth. When we go down inside the swimming pool, then uh, actual depth is more than the apparent depth. So what is the concept behind it? We discussed here, that is called normal shift, perpendicularly rise and up. So in case O is object where the ray is perpendicular, there is no change, but when it travel from some angle, there will be an angle of incidence and an angle of refraction here. So it travel from denser to rarer medium, it bends away from the normal. So away from the normal, this is the angle of incidence, and this is angle of refraction. When it travel from water to air, so this is angle of incidence and this is angle of refraction r. Now by the angle of parallel lines, these two lines are parallel, so I alternate angle, and R are corresponding angles. So we have to find real depth is HR and virtual depth is H dash, or we can say H apparent. So in triangle MNO, here we also have to take two triangle MON and MO dash N. O is object, O dash is apparent position of object. So in triangle MNO, sin I is equal to perpendicular upon hypotenuse. In triangle MO dash N, sin R is equal to Mn upon O dash N. Now W mu A, because light travel from water to air or medium to air, so W mu A is equal to sin I upon sin R, or we can say A mu W. It is a better to suit the find the value of A mu W. So A mu W is equal to sin R upon sin I. Now we have to put the value of sin R and sin I. So Mn upon O dash N and Mn upon On. Just upon to upon get reversed. So and Mn cancel. So A mu W is equal to On upon O dash N. Now On and OM are approximately same. In triangle they may be different, but in the symmetrical way, O dash M and OM we can find easily, or they are the approximately same because the depth is more but the angle is very small. So ON we can replace by OM, and O dash N we replace by O dash M. So OM is H and O dash M is H dash. So we get the formula A mu W is equal to H upon H dash. It is important formula. Or we can say there is a shift, apparent shift, normal shift from vertically the height, so that is called apparent shift is equal to H minus H dash. So H common 1 minus H dash upon H, or H dash upon H we can write as 1 upon A mu W. So apparent shift will be H 1 bracket 1 minus 1 upon mu. In this case we also discuss example that if a eagle see the fish, a kingfisher see the fish. So kingfisher see the fish is very closer to him, but fish sees from denser to rarer medium. So he fish looks fix fish appears eagle very far distance. Okay. Now next concept of today's class is total internal reflection. It is the very important phenomena in the days of communication. Optical fiber is a very known phenomena, or that phenomena comes from total internal reflection only. So what is total internal reflection? It is the phenomena of complete reflection of light back into the same medium for angle of incidence greater than critical angle of that medium. We know that when a ray of light, there is one foremost condition, that light must travel from denser to rarer medium. Otherwise, total internal reflection cannot be possible. When a ray of light travels from denser to rarer medium perpendicularly, no change in path. But when it gets some angle, a small amount of light get reflected and a small amount of light get refracted also. And it is denser to rarer, so it bends away from the normal. If we increase the angle, so I will get increased, then R will also get increased. At certain angle, the whole light get reflected back in same medium, all the refracted light get the angle of incidence, angle of refraction 90 degree. When the angle of refraction is 90 degree, this is called critical angle. In this case, we can write as we put a normal here. So this is I, and this I we conclude as critical angle. This is constant for a particular medium or pair of medium. This is called theta c, and in this case this is 90 degree. It means at an angle where the angle of refraction is 90 degree, this angle of incidence is called critical angle. And beyond the critical angle, now if we increase the value of incidence greater than critical angle, now there is only one chance to move back in the same medium. So if we increase the angle of incidence more than critical angle, now yes, I and IC R is equal to 90 degree. If we increase the angle more than critical angle, it will comes back in same medium. This phenomena, when it comes back in same medium, this phenomena is called angle total internal reflection. Now I is greater than IC and I is equal to R as a principle of incident reflection. So the condition for TIR, only two foremost conditions. First, angle of incidence ray must travel from optical denser medium to rarer medium. And second is angle of incidence is always greater than critical angle. Now there is a relation between critical angle and refractive index. So there we know that at the condition of critical angle, uh, glass to air, because denser to rarer, so G mu A is equal to sin I upon sin R. I is given as critical angle, but R at that time in the condition of critical angle theta equal to 90 degree. So sin 90 is 1. So G mu is equal to sin IC, or we can say A mu G equal to 1 upon G mu A. So A mu G equal to 1 upon sin IC, or we can say cosec IC also, cosec theta C also. Another formula for critical angle, sin IC equal to lambda G upon lambda A. It means red color have maximum value of critical angle and violet color have minimum value of critical angle. Now, application of TIR. What is the importance of TIR? So first and simple initial use of that or the application, natural application of TIR is mirage formation. Mirage is a concept which occur during daytime, very hot days, in the summer time, or we can say in desert, or we can say in highway. Sometimes we see the water filled on the road of highways, but when we reach at that point, nothing is there. So that concept is called mirage. So how it happened? We found the certain type of image in the blank media, or the on the road or on the desert. What happens and how it can happen? So it always happen in the daytime at the peak hot time, and we know that at the peak hot time means sun is there in the extreme heat. So desert, it means sand is more hotter than, so that medium is hotter, or hot medium have rarer medium. So this is the rarer medium. Or in the if we rise the height from the surface, so it is less hot, it means it is a denser medium. So when a ray of light travel from denser to rarer, it bends away the normal, and it is gradually. And if the angle of incidence increase, it will reach to the angle of critical angle. If it reach to the critical angle, it comes back in same medium. Now an observer somewhere in the same arena see the rays coming from in this light. So he observed that the image is here, image of an object in desert on the highway, where nothing is possible to get the image like as a water or mirror. So what happens? Because in the initial case, the ray of light travel from rarer to denser to rarer medium. This is the initial concept. A ray of light always travel from denser to rarer medium. So angle of incidence or angle of refraction increase. In the next later stage, angle of incidence is greater, more increase at the later stage when the angle of incidence is greater than critical angle. If it will gradually increase, it is greater than critical angle. Now it reflect back. It means now it is going from rarer to denser medium. Rarer to denser medium. So it bends toward the normal. It is the concept So the in desert we look like as a pond over here, but nothing is there. We in the highway we see that the water is sun is blowing on the road surface, but nothing is there. That is called mirage formation. So mirage formation, what is the concept behind it? We just go through it now. A mirage happens in the desert during hot days. Top of the object is in a less hot, denser medium, and the ray travel from denser to rarer medium. After traveling some time, it achieves the condition of TIR and comes back in same medium. Now it travel from rarer to denser medium and reach the observer's eye, so observer can see the image of object in desert. This is the diagram for mirage formation. Now just opposite of it, second example is looming. Looming occurs in cold countries, cold days in coastal areas. In the coastal area, cold season, the top of object, what happens over here? In the coastal areas where the desert and icebergs are here, so in the desert, in the coastal areas where ships are lying here and there, they are traveling from a long journey, there are iceberg also. So if a ship is here, so we think the ship region is more colder, the ship region is more colder, so light travel from it is from denser, it is travel from denser to rarer medium, because it is more cold, it is less cold, and as we goes above, it is a temperature increase because the water near surface is more cold, so denser to rare. So when a ray of light travel from denser to rare, so the condition of TR can occur. So angle of incidence, now the in second phase, it R will increase. Now on the second layer, when it again incidence, so R, since this R is greater than I, so in the late next stage, this I will again increase. At the some time, after some time, when this I is greater than critical angle, so now it comes back in same medium. It reflect back, or now it is going in uh, rarer to denser medium. So it bends toward the normal. So if someone lying over in another ships, so that person look like that his ship rays are coming from somewhere here, so somewhere here, so the ships is lying in the space, ships is in lying in the space, or ships have a certain type of dimension, but it happens with the iceberg also. So it is the most dangerous situations if a captain cannot find that it is looming or whether it is a real object. This is called looming. Now, application of third is the total reflecting prism. It is a right angle isosceles prism. It means one angle is right angles, the rest two angles are like a set square, 245 angles. We know that critical angle for glass is 42 degree, 1 upon mu c. So 42 degree, so 45 is more than critical angle. So when a ray of light travel straight, it incidence on this surface. So 45 is greater than 42, so it reflects back. So by this process, we can get the 90-degree deflection of mirror of the image like in a paracord. Second, use of same type of mirror, same type of prism, right angle isosceles prism, but now we use in the different way. So now in this way, we can get the inverted image, because we oftenly get the inverted image, a real image. Now we want to observe and analyze, so we get once ray incidence. This is now at that angle. At that angle, this angle will be 45 degree, which will be a greater than 42 degree. So again this is 45, so this will be 45, it means overall will be 90 degree. The same case happen here also, this is 45 and next angle is 45, so there is the 190 plus 90, 180 angle occur. So we get the lower portion in the bottom, and that portion which is should be upper, we get the inverted image to the erect image. So it is the second use of this prism. Third use, get the TIR by this also. So in this case, we get inverted image as erect image in the same directions, like in a spectrometer. So the ray incidence from this and this upper portion and the down portion. So we get the inverted image as an erect image. Now next application of TIR is optical fiber. It is the most interested, most important, mostly used nowadays in the technology. This is called optical fiber. This is the coaxial cable like a disc cable. Outer part is called cladding. It is a less refractive index media, and the center part is called core. It is a high refractive index media which associate to transmit the signal. So light travel through the core, but the cladding is used to get the condition of TIR. So when we insert any type of signal inside, there is an angle of acceptance. It cannot go through the any angle. There is an angle of acceptance. On that angle of acceptance, if a ray incidence on the surface of core, on the entrance of core, so it will get inside the core, and the cladding, which is a dense rarer medium, so it traveled from denser to rarer medium. But there is a phenomenon structure like that, that the condition STIR will possible here, so it reflects back in same medium. When it passes through that core and again hit on the second edge of the core or the different edge of core, again TIR condition will possible, always be there. So it will be transmit like this and this, and it reach to the second end of world also without loss of any signal. So this is the most important use of TIR. This is called optical fiber. So what is the optical fiber and how types we can say? There is the parts of two parts of the optical fiber. Core, high refractive index, provide path for the optical signal. Cladding, less refractive index, provide condition of TIR for the signal passes through core. Uses of optical fiber, transmission of optical signal. Wherever you want to transmit the signal by optical fiber, there's a 100% accuracy will be possible. Second, in communication. Third, in endoscopy, like a surgery or the breaking of stones or the breaking or rupturing of some cells, such as cancer and other type of cells. So endoscopy will be giving the best result because nothing will be lost here. Optical fiber can transmit multiple signal at a time without mixing and any loss. Any loss. So the accuracy will be, success rate will be 100% in medical and 100% quality communication in optical and communication. Next use is sparkling of diamond. Diamond is a very very costly ornament. So what is diamond? Diamond is a gems, brilliant because its refractive index is very high, 2.47. Critical angle is very small because as we critical angle is reverse to the refractive index.